Assalamualaikum. We are from Group D. My name is Nur Atisha binti Muhammad Zaliman 2118676. We chose the data set data cortex nuclear.csv that is retrieved from the UC Urban Machine Learning Repository website. This data is for the study that investigated the impact of protein expression levels, specifically 77 protein changes on the process of learning, aiming to identify the proteins associated with both successful and unsuccessful learning outcomes. The data for this investigation was obtained from a group of 72 mice consisting of 38 control mice and 34 Down syndrome mice, separated into 8 classes differing in genotype, learning stimulation and drug treatment. Next, I will be presenting some part of the coding. So here we read the data cortex nuclear.csv into a Panda data frame. So these are the columns and first few rows of the data. For data cleaning next, we will drop this mouse ID column, this genotype, treatment and behavior column. For machine learning model later, we will use this class column as the Y. So there are a total of 82 columns in our data. Next, we do exploratory data analysis on our dataset. So this is the descriptive summary statistic of the data. And this is the summary of data's information. This code is to count the total number of duplicate rows in the data. So as we can see, the data has 0 duplicate rows. Then we will use label encoder to convert categorical in class column into numerical. Next, we do data cleaning. So first we drop column with string, which are mouse ID, genotype, treatment and behavior columns. Then we copy the data into df. Then we print the percentage of null values for each column and drop rows with null values in column with less than 5% null values. Next, we replace remaining null values with the mean of each column and we verify null values are handled. So these are the results. Next, I will explain the code of feature selection filter method that we apply on our dataset. Any features that have STD or variance of less than 0.1 will be removed from the dataset. So the maximum number of rows and columns that will be displayed are set to 500 and the maximum width is set to 1100 characters. Then we use transpose to change from columns to rows and rows to columns to get the full view of the descriptive statistic of the data frame. So this STD column is what we really want to see here. Next, we get the rows where STD is below than 0.1. So as we can see here, there are a total of 46 rows that have STD below than 0.1 here. Then we use transpose again to change the data set into its original arrangement. So now we have 46 columns that have STD below than 0.1. Then we drop columns in the original data set that match columns in data STD which contain the columns that have STD below 0.1, and we put them into df filter. So now we remove 46 columns, so there are only 32 columns left. Next is machine learning model with feature selection filter method. So we call the function for K&N model for filter method. The accuracy, so this is the accuracy, this is the confusion metric, and this is the classification report for the K&N model using the filter method. So next we call the function for MLP model for this filter method. So this is the accuracy, this is the confusion metric, and this is the classification report. Lastly, this is the line plot for MLP training loss over epochs. That is all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. I'm Fatih Syafiqah binti Syafiq Adili. I will explain the code for feature selection using wrapper method. So first of all, we choose to use the sequential forward selection SFS. So we import the sequential feature selector as SFS, and then we set the number of features that we want by set the k underscore features to 5, and then we set the forward underscore true because we want to use the forward selection algorithm. If we want to perform the backward selection, we can set the forward equal to false. Then we set the floating equal to false because we don't want it to perform the floating algorithm. Next, we set the CV equal to 3 because we want it to perform the cross validation 3 times. Next, we can access the indices of the 5 best features directly through this k underscore feature underscore IDS underscore attribute. And then we can do the prediction score for the 5 features via this k underscore score underscore attribute. Next, we can plot the result after we import the function plotting dot plot underscore sequential underscore feature underscore selection here as plot underscore SFS. Then we generate the new subset based on the selected features by we use the trend set of the selected features and also the test set of the selected features. So that's all for feature selection using wrapper method.
I'm Anis Fazlin and I'll be presenting about the application of feature extraction in our dataset. So firstly, we initialize the X and Y for our dataset, and we split the training and testing data using the train test split, and then we defined the K&N function using this function, which we initialize 3 as the number of neighbors, and we fit the model into the train and into the X train and Y train, and we predict it, and then we evaluate the model using the accuracy, confusion matrix, and the classification report. And next is MLP model, which is the multi-layer perceptron. As usual, we initialize the parameter as X train, X test, and Y train and Y test, and then we use the MLP classifier here, and we set the hidden size of hidden layer as 128 and 64, and use the ReLU as the activation function, Adam as the optimizer, and we set the 500 as the maximum number of iteration. And also we set the early stopping. Firstly, we split the training data set. We split the data set into 20% of the training data and 80% of the testing data. And then we set the early stopping that we initialize using true here, that applied when there is no changes in the accuracy no changes in the performance of the model, three iterations. And then we set the random state here. As usual, we feed the model and we predict it, and also we evaluate the model using accuracy, coefficient matrix, and the classification report. Then, firstly, without any feature extraction and feature selection method applied to the data set, we feed and we predict the data set by calling the function here, the KNN function here, and we put the X train, X test, Y train, Y test as the parameters, and then we display the performance analysis. And here you can see from the given data set that has no any feature selection or feature extraction applied to, the accuracy for the data set for that particular model is 0.95. And this is the coefficient matrix. It is reflected to the accuracy. And for our use case, the metrics that are significantly useful for the analysis is precision and F1 score. Here you can see that the precision and F1 score are both considerably high, which is 0.95. And moving on to the MLP model, we call the MLP model, we fit and predict the MLP model by calling the function MLP here. And then this is the performance analysis of the MLP model that has no any feature extraction or feature selection applied to. Here you can see that the accuracy for the model, that particular algorithm, is 0.8, and the precision and F1 score for the particular algorithm is 0.3 and 0.97, which is considerably high, also high and also good for the data set. And this is the MLP training loss. Here you can see that the training loss is decreased and has stopped learning after 70 batches of epochs. And next is we utilize the PCA as the linear dimensionality reduction. First, we have to normalize the data using the standard scaler from the scikit-learn for preprocessing. And then we scale the data set into X-train scale and X-test scale. We use PCA from scikit-learn decomposition, and we use 10 as the principal components to retain the transform data, and we fit and transform it, and then we obtain X PCA train and X PCA train, and then we fit and predict that particular algorithm into the KNN model to test it using that specific X train and X test that we obtained from PCA earlier, and we display the performance. Here you can see that the model of the algorithm from the KNN model using the feature extraction linear method PCA earlier, we obtain 0.946 for the accuracy. And this is the coefficient matrix. You can see familiar that it is reflected from the accuracy. And the precision and F1 score are both, we obtain 0.95. But you can see from earlier, the accuracy of the model is slightly lower than the algorithm that we obtained from KNN earlier, from the data that has no any feature selection or feature extraction applied to, which is I think 0.952 earlier, and this is 0.946. But however, it is good for the data set. And then for using MLP function, we can fit and predict the data into model by using that particular X-train and X-test we obtained from PCA earlier, and we fit and predict it using the MLP function. And this is the performance analysis using the MMP function of the feature extraction linear method PCA that we used earlier. Here you can see the MMP model accuracy is quite high, which is 0.952. And then here from the classification report, you can see that the precision and F1 score is are both 0.95 score, and also are considered quite high score for the data set. And we can deduct that it is good to use feature as PCA for the MLP function, because can obtain overall good score, overall high score for the given data set. And here you can see that MLP training loss has decreased and has stopped learning at 40 batches of epochs. For the nonlinear dimensionality reduction, we use a kernel PCA model that we obtain from circular decomposition, and we use 10 as the number of components to retain the transform data, but instead of we use the default kernel, which is linear, or from the PCA, we use sigmoid kernel. And then, as usual, we fit and transform it, and we can obtain our specific X train and X test from the sigmoid PCA itself. And then we can fit and predict the model using the KNN function using the specific X train and X test. And here is the performance analysis using KNN model for the particular data using that apply feature extraction nonlinear method. Here you can see that the KNN model, the accuracy of the KNN model using the sigmoid kernel PCA is 0.228, which is not very good. And here you can see that it is reflected to the confusion matrix. And for the classification report, the precision and F1 score for this particular model and algorithm is also exhibit similarly, which is 0.24 and 0.23. Next, for the MLP model, we fit and predict the data using the model MLP using the MLP function here. We call it, and we put X train and the specific X train and X test that we obtained from sigmoid kernel PCA earlier, and we display the performance analysis. And here you can see that the accuracy of the algorithm and MLP model using the sigmoid kernel PCA is 0.52, and here you can see that it's reflected to the confusion matrix. And for the classification report, it has precision and F1 score of 0.17 and 0.13, which is also considerably quite low for measuring the performance of the model. And here we can deduct that it is not quite suitable for the given dataset, for our dataset to use the nonlinear sigmoid kernel PCA as the feature extraction as the optimizer for this dataset. And here, as usual, you can see that training loss over epochs has decreased and has stopped learning after 17.5 batches of epochs. Thank you.